everybody. I'm Yurii Mednis, a software engineer from EPAM. I believe technologies should make our life easier, happier, and provide more resources for less money. Blockchain is a great technology, but mixing technologies can be even more profitable. So we decided to go further and combine self-driving cars and blockchain. Buber. What is Buber? Autonomous cars will appear on our roads in large numbers soon, and they will be in private and commercial ownership. Autonomy will allow the use of private cars as a source of additional income when its owner is not using the car. For example, during working hours, during resting at home after work, or during vacation. One such possibility is an autonomous car. An autonomous car connects to a smart contract via special application and can earn money for its owner. We developed a POC of such autonomous taxi and call it Buber, blockchain Uber. The innovative POC and field tests were created within Made Real Lab. So let's move to the taxi industry. And the current taxi market is mostly the market of big taxi aggregators, such as Uber, Bolt, Grab, and Didi. When these giants appeared, they completely changed the game, the world of taxis. They reduced the prices and made the experience easier. But what are the commissions nowadays? So Bolt is up to 20% commission, Uber up to 25, Didi up to 13, Grab up to 20. Is it a lot or little? To understand it is required to know what actions are performed by a platform. So in this case, let's go to the next slide. Taxi platform goals. Connect clients and drivers and provide a reliable platform for communication. For connecting millions of people, the platform should be distributed, reliable, and network disruption protected. Proceed the payment. So everyone wants the confidence that the client will pay, that the driver will perform its service. So, and everybody wants to receive a declared amount of money for their service and declared service for their money. Settling the disputes. So it is required to regulate fraudulent client-driver behavior and malicious behavior. The corner case situations arise in every area. And even if the percentage of such situations is not big, handling such problems require a well-established system for resolution. And it should be well tested. Next is verification, car client information, verification of car characteristics, driver license, and so on. So essential information such as technical state of vehicles, controlling this technical state, driver's licenses, and other legal documents should be appropriately verified by the officially approved procedure. And this procedure can vary depending on the country. And of course, the goal is build the client driver reputation, because everyone wants to have a deal with honest people, with an honest driver, with an honest client. So it is required to keep the track of right history and reviews. So it will be required to collect, pass, and classify the right history information, which allow filtering malicious and rude persons. So to form the client driver reputation. So it's a big word, reputation. So which of mentioned activities blockchain can be involved in right now? Later, I will use the term driver, but it means both the ordinary driver and a self-driving car, because as we mentioned, we are living in in the world of future, in the world of self-autonomous cars, and we tested our application with also with Tesla. Let's go to the next slide. So connect clients and drivers. So blockchain is by default a reliable platform for communication. So it is a distributed digital ledger by its mean, a distributed database that is available 24 hours a day, 7 days a week. Next, proceeding the payment. So blockchains are already used as a payment system for many projects. And Buber smart contract is used as an scroll. So money from a client are blocked when the write is started and transferred to the driver when the write will be completed. And a small contract fee remains on the smart contract address to provide work of offline services, to provide the work of the platform. So both the client and the driver are protected, and everyone is happy. So next slide, settle the disputes, verifying driver client information. So this is the place where offline services, oracles, which can act as oracles, come into play. So sometimes disputes and right reconciliation cannot be done in an automatic way, and it will require additional clarification, possibly on the phone, inside our application, by email, and so on. So I mean, offline, this is offline on blockchain. And that is where offline services can help. During the call to the smart contract, which requires offline examination, an event will be triggered, emitted, and appropriate Oracle service will be triggered, and service will clarify the details and complete blockchain operation. We will return to this specific point later. So build the client, and what we are looking into the future, and in the future verification of essential information can be, for example, registration of car can be delegated to smart contracts, which will be provided by the government. In this case, a special contract will exist, which can verify that the appropriate address matches a specific driver car address, can be verified by its digital signature. Estonia and Ukraine actively work in this area using signing by digital signatures. Build the client driver reputation. As we already mentioned, blockchain is a big database, a big distributed ledger by default. So as a result, all information about rights, ratings, and reviews can be saved in blockchain and then processed by the applications and represented to the final users in a convenient way. But what about challenges? As we already mentioned, that transaction history with the right information is available to the whole world. And since that addresses inside blockchain are pseudo-anonymous, so with a small social engineering or some kind of error, the matching between real world person can be established, and the whole world will know about the rights history of a particular person. The next challenge is scaling. Although after moving to L2 layer, Ethereum blockchain will be able to proceed up to 100,000 transactions per second, possibly in some time instead of tens of transactions. So it still can be not enough, because in peak hours it can be millions of write requests all over the world. So this is a real issue, and it is required to find a solution for the future delays. So the number of blocks that should be mined to confirm that the transaction was completed, it depends on the organization policy. But even mining one block right now is about 12 seconds. And such delays will affect usability, because in real life, in our modern life, user want to have feedback immediately. So let's move. I will shortly describe what technologies were used during writing a smart contract. So the smart contract is written in Solidity language and deployed to Polygon testnet. And it was tested, deployed, and worked with smart contract was via Hardhat. So let's move just to a simple use case scenario which provides information how the write will be performed. So at first, the taxi client application will call to smart contract, and it will place a trip request. It will specify its destination, pickup location, And during the call to smart contract, the event will be emitted. So taxi driver applications will scan for the events. They will pick up the interesting events for taxi driver application, and it will place an offer. So it will specify ride cost, which is suitable for the self-autonomous car, which will be calculated via the artificial intelligence or with some algorithm, and time to wait. So this also event will be emitted, and taxi client application will choose the suggestion which will suit it the most, and it will initiate the ride. So in this case, it is during this call, the required amount of tokens, I specified as, but it can be any token, so will be transferred to smart contract. Then taxi driver should, I think, self-autonomous car should accept this car. It should arrive to the destination and signalize to the taxi client that the self-autonomous car was arrived. And when the client will get to the taxi, it will start the ride. Then when client will arrive to the destination point, it will complete the ride. And the final step will be complete the ride from the self-autonomous car application. During this call, self-autonomous car will receive its tokens, its ride cost value, and a small amount of ride cost will go to smart contract to support the infrastructure and offline services. So let's look how this can be implemented in a slide. For example, on the example of registration of the car, of the taxi. So taxi application, self-autonomous car application will call the smart contract. It will specify model, license, year, registration number, and all other information which is required to a smart contract. And smart contract will emit the event. The offline authority will, it can be not a single authority. It can be, for example, a bunch of offline authorities. And each authority can, for example, can proceed this event. It will communicate with the taxi driver to verify that taxi is who he claims to be. And after verification and offline communication, this offline authority will call to, will make a call to smart contract and confirm the registration. And of course, this offline authority should be in the list of roles in our smart contract, which only allowed to confirm such registration. Okay, so as I mentioned, smart contract and application, it is working in some kind of symbiosis, and smart and application was developed and implemented by my colleague, Aliaksandr Salnikau. So Aliaksandr, please proceed, it's your turn.
Thank you very much, Yurii. Let me share my part of presentation. I hope you see my presentation. Hello, everyone. My name is Aliaksandr, and I'm a software engineering team leader at EPAM, and one of my key skills is Android development. So I haven't been in the blockchain world for a very long time, maybe a year or so, but I really like how fast this technology is growing and how many challenges it has, how much lessons we have to learn. So today I will describe Android part. our Android application and technologies we used to build it. We have two applications. First is mobile client for passengers with possibility to create a special blockchain wallet to make payment and request a car. So dev setup for client development is pretty simple. It has pretty standard Android tools, but also we used some blockchain specific tools. So for Android application, the main language was Kotlin and Android Studio as a main dev environment. Also, we used a lot of Google Maps services because we have a lot of work with maps and routes. Besides the standard Android dev tools, we have a lot of working. We used a few specific tools for blockchain because we have to communicate somehow with blockchain. So first of all, a blockchain is a public database, as Yurii mentioned, that is updated and shared across many computers in a network. And Ethereum is a blockchain with a computer embedded in it. So in the Ethereum universe, there is a single canonical computer, which called the Ethereum virtual machine, whose state everyone on the Ethereum network agrees on. Everyone who participates in the Ethereum network keeps a copy of the state of this computer. And a smart contract is a code that lives in the Ethereum blockchain and runs exactly as programmed. And to communicate with Ethereum, we used communication protocol in Ethereum universe, which calls JSON RPC. JSON RPC is a remote procedure call protocol encoded in JSON. It allows for notifications when data sent to the server that doesn't require a response, and for multiple calls to be sent to the server, which may be answered asynchronously. To work with it, we choose library Web3j. Web3j library has been chosen to work with Ethereum blockchain to have possibility to work with Ethereum without additional overhead of having to write own integration code for the platform. Else, Web3j is a modular, reactive, and type-safe Java library, so it can be run as command line or backend application or Android, part of Android application. And it allows working with smart contracts and integrating with clients on the Ethereum network. And this library is pretty mature and has a lot of features, but on client side, we used only few of them, like wallet support feature to create and manage our Buber wallet, generate of Java smart contract wrappers, reactive functional API, and command line tools. Usage of Web3j library is pretty simple. The first step is to compile the smart contract using Solidity compiler. And the second step is to generate wrappers with Web3j command line tool. Web3j will generate source code in Java class. It will call Buber Java in our case, with all methods, events, and structures which are defined in smart contract. After that, to call smart contract methods in our Kotlin application, in our Android application, first of all, we need to initialize Web3j service and load smart contract calling static method load. In our case, it will be buber.load. And that's it. Now we can call smart contract methods and interact with blockchain world. Another must-have tool is Hardhat. Hardhat allows us to deploy smart contracts, run tests, and debug Solidity code without dealing with live environments. As a client developer, I didn't use debug features, but I use it to run Hardhat as a local Ethereum network to run our smart contracts. How to run it? It's very easy. As a first step, start not on local machine and deploy smart contract. And that's it. We will have a local Ethereum network running on your dev machine, and you can use local host to make calls. Another tool, but it's not just a tool, it's a network. We used Polygon. What is Polygon? Polygon is a layer 2 or sidechain scaling solution that runs alongside the Ethereum blockchain, allowing for speedy transactions and low fees. Polygon has its own native currency, Matic, and Matic is the network's native cryptocurrency, which is used for fees, staking, and more. All transactions fees and right payments in our applications made in Matic. Polygon has main test and has a test net, Mumbai. The Mumbai testnet is the testnet of the Polygon network, which replicates the Polygon mainnet. Like the main Polygon net, it is a layer 2 scaling platform for Ethereum, and it allows developers to deploy and test the applications on the network without having to spend real money. Next steps. Original idea was to implement IoT device, and we will continue work on it to develop IoT device and implement it into autonomous car with possibility to communicate with different services and payment for them, like parking, car wash, car charge, etc., etc. Also, for our clients, we have a few steps. First of all, it's hard to listen smart contract events all the time because client may close the application, internet connection may interrupt. So driver or client application may miss some orders from passengers. Passengers may miss some offers from different drivers. So we will integrate the graph. The graph is an indexing protocol for querying networks like Ethereum, Polygon, etc. And with the graph, we plan to make specific query to fetch data from blockchain and to find orders and offers after restart of application, for example, etc., etc. The next challenge is chatbot and messaging. Taxi requires some form of communication between driver and passenger application, for example, to notify client that car is arrived. So we want to implement some kind of communication protocol, and Vaku may help us here. Vaku is a family of peer-to-peer protocols for secure communication. Some of projects already used Vaku, Status AIM. Status is a secure messaging application, crypto wallet, and Web3 browser. Another very famous Wallet Connect. Second version of Wallet Connect is also using Vaku for decentralized messaging infrastructure. So thank you for watching, and any questions?
So thank you, Yurii and Alexander, for this interesting talk. I think Buber can change the whole face of public transportation through CATS. So we have some interesting questions from the audience. So I just want to mention that the participants in the session will also get free NFTs through their emails. So please keep your questions coming. So we have some questions. Let me just take some interesting questions. So one of the participants asked, so there will be no surge pricing with Buber, and if not, who fixes the taxi fare with the Buber app? Somebody, one of you can take the question.
So the question is, will the price for the will the ride cost will be less than in Uber?
Yes. And who fixes the price? What is the determining factors that will fix the taxi fare? So
in this case, the price will be suggested by self-autonomous cars or by drivers. So it will be not so the price will be regulated by the market. In case, for example, it will be a great in the peak hours, self-autonomous car will have the possibility to choose who will suggest more and to accept only rides from the accept only rides and suggest the price which is suitable for the car. And in other way, the same is for clients. The client will choose who will provide the less price for the cost. So it will be it will be regulated by the market. And I think this was one.
So there will be transparency in pricing in the sense that client can choose the lowest fare and the driver has the flexibility to fix the price for that particular ride. Correct?
Yeah, correct.
Perfect. That's a cool
correct.
Thing. Yeah, thank you.
Thank you.
Then the next question is, I think it's a very trivial question. I'm not sure whether it's trivial. What about the accident insurance for the Buber driver and passenger if they use the app? So I believe that for traditional taxi services, there is a accident insurance coverage that is there provided by Uber and other taxi cabs. So what about Buber? Is that a particular feature that is considered with this particular service?
Yeah, so you mentioned the step which was registration of the self-autonomous car. Of course, it will be in the future. So we are providing the ground for the future for when legal procedures will allow to use self-autonomous car, we will already have a working solution in this case. But for the ordinary drivers, during the registration, we will go to offline services. And in fact, Uber and all other aggregators, Bolt, they verify the driver license, and any other official documents. And these offline services, our offline services, will do the same. Okay. But the reason is that part of the responsibilities of the current taxi aggregators, they will be performed by our smart contract. And so, and smart contract, since the smart contract will take a small, less amount of money by commissions and by during the gas, during the transaction when the gas will be consumed. So that is the idea.
There is no zero commission, but then there will be a small commission compared to other taxi aggregators that will be used to maintain the infrastructure.
Of course. So, for example, we will have a commissions which will allow us to provide good service with offline regulation of different disputes and with providing the services which will allow to register car and so on. But the commissions which are paid to taxi aggregators, such as for supporting and providing the platform, blockchain is platform by default. So, and that is why, and it will be the free market. That is why commissions will be less, because all commissions for supporting the platform will be only consuming the gas.
Okay, understood. Thank you so much, Yurii. Next question is posted by Sandeep. So basically what Sandeep asked is, can you explain and show the Solidity code? And if I understand correctly, the smart contract is developed separately to the actual Kotlin Android code and deployed on to the ETH testnet. Is the question clear?
Of course, we will provide the link to the source code of our smart contract. And right now, the smart contract is deployed inside Mumbai testnet on Polygon, and application uses this smart contract. And I think about application, Aliaksandr can provide more information about how application is interacting with already deployed smart contract.
Yeah, we use actual version of smart contract to generate wrappers and properly call RPC methods. For example, to initiate the ride or place an order or place an offer for particular order. Yeah, and smart contract is currently available in Mumbai network.
Okay, thank you. The next question was, what are the main challenges that you faced in the blockchain development for this use case?
I will. For example, Aliaksandr, you can start. Or I can explain what the challenges was for a smart contract implementation. I think the main challenges were to implement and design the infrastructure and the future iterable steps to implement the future product which can be available. So just to walk through all the steps to understand how the ride can be constant, and in almost like in any application, the most tricky things are corner cases. So corner cases can just be less than 1%, but it will require to implement many different solutions and so on. So for me, the main challenges were to develop the architecture and to know how to communicate and what will be the procedure to communicate with offline services and what will be, this will be procedure.
Yeah, but for me, it was more challenging because I had some experience as a regular user of blockchain, but not as a developer. So when you know all necessary tools, development is pretty simple, pretty interesting. But when it is a new area, new technology for you, learning so many tools, reading documentation, and creating appropriate and flexible architecture of client is pretty hard, but it is very, very interesting and challenging task.
Okay.
Sorry, another one thing for me. I think that the most challenging was testing, as usual. So it was required, since this is POC, and we eventually did not cover all corner cases, and we only in the beginning of our way, but to test simultaneous work of several requests and so on, to test everything properly, to make a long test which intersection of different requests in different stages and so on. So for me, yes, eventually I think from the technical point of view of writing smart contract, it was testing.
Okay, so also continuing with the question, so has there been a customer value proposition test also done in the market as well, whether there is a product market fit for Buber as well? In the sense that have you gone to the market, to the real world, and test this product concept idea with potential customers as well, and what was their response of such a unique idea?
As we mentioned, we have a lot of challenges for future, and we have to apply new technologies in our application. After that, I don't know, maybe, who knows?
Yes, so as you mentioned, so we are working on implementing the already working solution for future legal for future legislation. And for example, our made real lab, so we are working with integration of IoT, Internet of Things. For example, our application in future, it will be connected not only with our smart contract, but this application will be some kind of ecosystem. And this ecosystem, for example, can include working with a parking lot for self-autonomous cars. For example, we will have a smart application which will introduce NFT, which allow to park on a particular place in a parking lot. And we are working in the area of integrating IoT, blockchain, and self-autonomous car. And this is, I think that, as I mentioned, we're only at the beginning of our long journey. So, and I think it was no, as I know, official suggestions to the customer, but that is why we are here on the conference. So to tell about our solutions and about our work.
Absolutely, absolutely. So let's go to a technical question. You showed using hard hat for ETH testnet, where the smart contract was deployed. So where and how was Polygon used?
Again, could you please
yeah
repeat?
So you showed using hard hat was used for ETH testnet, where the smart contract was deployed. So where and how was Polygon used in the whole product?
So Polygon use the smart contract written in Solidity can be deployed to Polygon as well. So because Polygon uses EVM standard Ethereum virtual machine, so and it can be used just calling smart contract functions, some smart contract calls in the same way.
Okay. I can say that usage of Hardhat for me and for Yurii was a little bit different. Yurii, as a smart contract developer, used Hardhat for debugging and testing of his smart contract, and I, as a client developer, I used Hardhat as a local Ethereum network, and I used it on earlier steps when contract wasn't finalized yet, but after finalization of all methods, data structures and events, Yurii deployed the smart contract to Polygon network, test network, and after that, our clients was able to communicate through Polygon test network, not only from local host. So before Polygon, usage of clients was limited, and it was required local instance of Hardhat, so you wasn't able to request a taxi on the street, for example, without my instance of Hardhat. But now, after deployment to Polygon network, you can use from any place in the world with internet connection.
Okay, thank you. So we have one final question, which was, how do you see the future of Buber to be? So you already mentioned, Yurii, that you also want to look at self-autonomous cars as well to be included in the app. But then where do you see the final state of Buber as an application? How it will change the life of a customer using it?
In the future, I see it as possibly as some kind, not a replacement, but in a most successful way as a replacement for current taxi aggregators. And I believe in technologies. I think that blockchain should replace where it is possible different aggregators and provide more concurrency, more collaboration with different other smart contracts. And as I mentioned, for example, in future, I think that registration of car will be provided by governments via special smart contracts. It can be not, for example, EVMs, Ethereum blockchain, but hopefully it will be Ethereum. And it will, our application will integrate not only this, as I mentioned, smart contract, but smart contract with work with smart parking lots and so on. So it will be like some kind of ecosystem. Thanks.
Okay. I think the future is really bright, looking at how you envision the product to be affecting the clients and the customers. So thank you so much, Yurii and Alexander, for this enlightening talk, and wish you all the very best. And just a reminder to the participants, for all the questions that you have posed, thank you for that, and you'll be receiving your NFTs in your emails shortly. Thank you everyone for joining.
Thank you for your time.
Thank you, everyone.
Thank you.